Okay, so we got heat transfer. Heat transfer is what direction?
Hot to cold.
What?
Hot to cold.
Hot to cold. Hot to cold, okay. So, what we're gonna do is we're gonna look at the structure of a house. So the heat is gonna travel from the outside to the inside in the summertime, right? You good with that? And in the wintertime, it's gonna go from the inside to the outside. Okay, it's important for you to understand that, especially when you're troubleshooting, you're gonna look, okay, where am I losing my heat? Am I losing my heat from, which direction is the heat flowing? So, you will also notice in the summertime, hot is going to cold. When your air conditioner's on and you open the front door, you feel all that hot air. Cause it's coming, that hot is going to cold. The opposite, in the wintertime, you open that front door and you can't feel the cold air, because the heat is going out. Wow. Okay, so, like I said, large amounts of heat leakage through the walls. So this is a problem that we're gonna find it happening. So what we're gonna do is we're gonna break down the walls in layers, because we know that heat's gonna travel through certain materials at different rates than other materials, right? So if we've got this wall, then the heat's gonna travel through this first layer maybe slower than it travels through this middle layer or whatever. But we're gonna actually look at it and we're gonna diagnose it, dissect it. You wanna dissect? Ready to dissect, okay. I'm gonna tell you a little story. Way back in the 50s and 60s, right? Remember back then?
Yes.
And in the early 70s, sizing air conditioning was simple. They had a certain chart that they used. It was like that. That was the chart they used. Okay, so by using that and by doing that, the people that were doing the air conditioning, the contractors and stuff, were either oversizing or undersizing. Because they didn't know exactly, they just, air conditioning, hey, air conditioning. Because air conditioning just started becoming popular. And a lot of the houses that were built in the 50s and early 60s didn't have air conditioning on it. They had water coolers. So they weren't really popular. They were too expensive for everybody. So when they started retrofitting and they started building houses with air conditioning on them, then they come into a lot of problems because they oversized or undersized the units. Which is fine, because that went on for years. Until the mid-70s. You guys know what happened in the mid-70s?
Mandatory to have air conditioning.
What?
It was a law to have air conditioning.
I'm gonna tell you. You don't remember the 70s? I remember the 70s. This country went through what they call an energy crisis. Okay, OPEC raised their price of oil, caused the entire country to go into an energy, well, it was a crisis. We went into energy saving mode. And one of the things they looked at was everybody that's got air conditioning on their house, that was the biggest use of electricity. So during that time, I'll tell you how bad it was. During that time, the price of gas went from 29 cents a gallon to 59 cents a gallon. and everybody freaked. What is it now?
It's $5. No,
$4 where I live.
$5.
$4 at Costco, that's cheapest here now.
So, and what was happening was people were siphoning gas out of your gas tank in the middle of the night. So, it was bad. One of the things they did was, they closed the gas stations on Sunday. You couldn't get any gas on Sunday. There was lines, like, you know, there was lines like around the block waiting to get gas. So a lot of gas stations ran out of gas, they couldn't get any gas, and that's why they closed them on Sundays. And they implemented a nationwide 55-mile-an-hour speed limit. Conserve fuel. So it was a big thing. And then what happened with the air conditioning, they came out with Title 24. Title 24 looked at the air conditioning units in the residential sector and said, we gotta do something about this. It's a lot of energy we're using here. So from 1975 or so, our industry changed. Title 24 came along, they changed building codes, they changed air conditioning specifications, made sure the air conditioning were energy efficient, or they started making them energy efficient, and they started making the homes with insulation. So any new home after 1975 had to have insulation in the walls. Before that, they didn't put insulation in the walls, just in the ceilings, and then it was minimal. Some houses didn't have any insulation in the ceilings, none in the wall, none in the ceilings. So they knew that a lot of the heat and a lot of the cooling, the heat was escaping right through the sheetrock and stucco, you know, without, so that's when they implemented, starting to put R13 or R11 insulation in the walls, and I believe there's a minimum of R22 in the attic. Okay, so that was after 1975. Okay, got that so far? Okay, so when we're gonna look at building, and we're gonna take the walls, and everything's gonna be figured according to square footage. Okay, so you got heat transfer here, got 100 degrees here and 75 degrees here. See that? What's the difference? 25 degrees. That is the delta T. The delta is just the fourth letter of the alphabet, the Greek alphabet. And it just means difference. So the delta means difference and the T means temperature. So the difference in temperature is 25 degrees. Okay? We'll use that term a lot in the trade. It talks about delta T a lot, especially in the book. Okay? Okay, so in the handout that I gave you is table 8.4. Now this is gonna list building materials and a rate of conductivity of heat through those materials. So when we look at the columns, we'll take, for instance, gypsum. Anybody know what gypsum is? You know what gypsum is? What?
I don't know.
Okay. Drywall. Sheetrock. This stuff. Made out of gypsum. That's what they call it, gypsum board. Okay? So we take that. Now the gypsum board has what they call a K factor, or conductivity rating. It also has a conductance rating. So the conductivity and the conductance are two different things. If we look at gypsum, it gives you two sizes, or two thicknesses of two of the common sizes of gypsum that comes in, either 5/8 or 1/2 inch. So if it's 5/8, you can go over here to that's your number right there, 1.78. If it's half inch, it's 2.22. So these numbers, we'll get used to using these numbers. On this column here is the R value. So we got K, C, and R now that we have to deal with. Whoa. Anybody know what the R value is?
Resistance.
Resistance. That's what it means, resistance. That's how they rate insulation. You ever notice that in Home Depot?
No.
You ever go to Home Depot?
Been there once in my life.
Yeah, we'll go down the insulation aisle. And it says right on it, the R ratings. So the R rating, it's interesting that the only thing that's actually rated in R values is insulation. That's the only thing. So you can buy gypsum board, you can buy any one of these products or any one of these materials, it's not gonna give you an R rating.
It's only just,
It's not gonna give you a K rating or a C rating. It's just gonna tell you, this is a 2x4. And it's this much. Or this is a piece of plywood. It's costs this much. That's all they're gonna tell you. They're not gonna give you any indication on how heat is gonna travel through that material. That's where Title 24 came in, and this chart is from Title 24. So these are all the buildings. They have something like that in the book too. It's in Unit 42. It talks about this. We don't do Unit 42 because I do it here. No sense in redoing stuff. Okay, so on this, there's also another page, and it talks about air film coefficients, which is right here. What those numbers are for air film coefficients. We're gonna go through and we're gonna break a wall down. And we're gonna go step by step, and I'm gonna show you how they did it back in 1976. This was all done by hand, just like we're gonna do it. Since then, when I went to school in '88, they had companies that just did Title 24 for the plans. You just give them your plans, and they run a Title 24 all on computer. And then they give you back the plan with all the Title 24 specifications on it. But before that, they had to do it all by hand. And I know that because I had a set of plans one time that I had to get from the city. And I talked to the architect, because I had to get permission to get copies of the plans. And some of the sheets that I copied actually had the Title 24 all hand figured out. And he even asked me, he goes, I can't remember back then, it was 1976, he goes, I can't remember if I had a program to do Title 24 or not. And I said, no, you didn't. Because it was all done by hand. Oh, okay. Anyway. So, this is gonna be our formula. We're gonna mainly go down, right? Q. Q is what we're gonna do, is we're gonna end up with a Q number, which is total heat in BTUs. Now the heat gain, or the heat loss, when we end up with Q, is gonna be basically the size of air conditioning we're gonna use. So whatever loss we have in the Q value is what size air conditioning we're gonna need, okay? This is exciting. It's exciting. I'll tell you, this is one of my favorite podcasts. Okay, so area in square feet is the A. The U is a conductance factor, which we'll figure out, and the temperature difference. So all of those three factors have to be figured in to figure out the total heat loss or heat gain. You with me now?
yeah.
You getting this? We haven't got anything really, yeah.
A-okay.
Okay, so we have a wall that's cut away. So, this is what we're gonna do. This is how we're gonna do it. Where's my? I want the black one. Another one. Okay, so when we do a breakdown of a wall and we cross-section it out and we look at all the materials, there's two factors. If we go back to, the handout, where it says, I don't have one here. Air film coefficient, I think it's on page 115. On the handout. Also on our. See it? You see it? See it? You see it? See that? Right there. Yeah, right there. See? So what does it say about air film coefficients?
Do you want the formula?
No, I want to, what does it say? Read that back.
Air film coefficients. Heat flows from the outside air to the outer wall surface and from the inner wall surface to the inside air by radiation, convection, induction. The time rate of flow at these surfaces, combining the effects of all three methods of heat transfer, is known as air film coefficient or surface conductance. F and BTU per hour per square foot per Fahrenheit degree difference between the surface and the surrounding air. The metric units of F are W.
Yeah, we don't want to metric.
Yeah.
We're not metric. Okay, so it's telling you that the air film along the inside of that wall and on the outside of that wall has an insulating effect. So that has to be considered into this formula. So the factors, the air film coefficient, for, we'll start with the faux, which is the outdoor air film, because you have a phi over here. It's just phi and faux. No phi and no foam. It's just phi and faux, okay? So if we look on the handout, it's gonna give us our coefficient for the faux. Right? You see it on there? What is it?
6.0 BTU. You want the whole thing?
No, I just want the coefficient. Outside flow equals
So the whole thing?
that.
Just, oh, 6.
6. So, that is 6. Let me check this out. So that factor is gonna be 6. Okay? Just like that, okay? Comes right off the chart. The formula for that is gonna be 1/6.
Over 6.
The reciprocal. What we're gonna do by doing this, we're gonna convert that air film and all of these other materials into an R value by reciprocating, so we can add them all up and we'll come up with a total R value. And then I'll show you what to do with the R value. Exciting. Okay, so what's 1 divided by 6?
6.
Is that an apple? Yeah.
0.1666666.
1.67?
Yes.
No, point 167?
Yep.
Okay. I carry them out about 3 times, because by the time we're done with this formula, it gets us closer. So if you do 3 and somebody else does 2, your number's gonna be pretty far off, so by the time you're done. Okay, so, now, here's where it gets tricky. So we got brick, the next component there, and we look at this and it says 4-inch face brick. So we have that on our chart, our table.
Yes, we do.
Oh, you do.
High density.
High density, right? High density brick. Okay, so is there a number or high density brick.
Maybe it's for conductivity,
Yeah.
but nothing else,
Huh?
but nothing else, just conductivity.
Yeah, we're gonna have to figure out what the conductance is.
How you do that?
What's the number?
9 for conductivity.
9. So we've got 9 for conductivity, and because we don't have a standard size of thickness, we have to put the size of thickness in there. Okay? Follow me? Follow me? Get it? So it is, let's see, I gotta make sure I've got this right. Where's my
Cheat sheet.
There's my little sheet here. Yeah. Oh, I got a copy of it right here. Okay. So, I don't have the rest of it. What we're gonna do, on the handout, this is where it gets confusing. With that. Cool. One more. One more. One more. I wanna look at the formula. See, here's a formula down here, so it's gonna give you the thickness and then the K value. So anytime there's not a standard thickness, it's gonna be thickness over the K. So we got 4 inches over 9. So that's the formula for the conductance, for the conductivity.
Thickness over the what?
Conductivity, conductivity. So it's either gonna be conductance or conductivity, so that's why it says up here, K or C factor. The K factor is where you're gonna have to put in the thickness in inches.
0.44.
Okay, and we'll have to do that a couple of times on this, so. What do we got?
0.44.
0.44? 4?
Yep.
444, okay. Okay, so now it looks like we have 3.5 inches of airspace in between, inside that wall. So if we go back to our aircraft coefficients and we read that second paragraph, what might it say? What might that say? What might that say? What might that say?
Airspace in walls also conduct heat by all 3 heat transfer methods. Let A be the thermal conductance of the airspace in figure 8-4. With the thickness of airspace being considered if the airspace is 3/4 inches, 3/4 inch thick or more within a structure. The value of A would be taken as 1.1 BTU. If there is no reflective insulation in the airspace in the metric system.
Okay, it's saying 1.1. Is it more than 3/4 of an inch?
Yes.
Oh, yeah.
Definitely.
So our airspace, C factor is 1.1. So we're gonna reciprocate that to 1/1.1. And that's gonna give us what?
The resistance.
0.909?
Yeah.
0.909. Okay. So is it on this?
So would you get the 1.1 again? That's just because it's,
It's in that paragraph,
where you're.
talks about the airspace in walls.
BTU.
Okay. Sheet rock, we got 5/8 sheet rock. Okay, so if we go to our chart, and we look up, what is sheet rock?
Gypsum.
Gypsum board, right?
Is it? 141? Sheet?
That's what sheet rock's made out of, gypsum.
I thought it was actual one.
they don't make it out of rocks.
Over bricks, man.
Okay, so it has a K value, but it also has 5/8 inches. In case you didn't know that, 0.625 is 5/8. 5 divided by 8, right? Okay, so we can go over there to 1.78, right, you see that? 1.78. 1.78, and that reciprocated 1.78. And that might be what? 561, 0.561?
Yeah.
I was right? 0.561 for our R value. Now, this is where it's gonna get funny here, paneling. So if we take paneling, what is paneling? It says it's a 1/4 inch. So paneling is basically plywood. So we can take the plywood and take the K value of the plywood and divide it into 1/4 inch. What?
So we take that and the K value divided by the 1/2 inch?
Yeah. Divide it into. So what is it? 0.81? Let's put it up there so we know. 0.81, and we have 1/4, right? So what's the decimal of a 1/4? 0.25 divided by 0.81. And that's gonna give us what? What's that?
Yeah, 0.308.
Point
308.
0.308? 0.308?
308.
0.308, okay? We got one more. Now we're gonna go for the feet. Remember where we get the feet?
That's right here.
1.65.
What?
1.65.
1.65 is the, yes,
Okay.
yeah, you're right. 1.65 is the C factor. So that is reciprocated 1.65, and that comes up to 0.606.
606.
How do I know that?
Cause you
Too
did this
smart.
morning.
I did it already. Once before. Okay, so if we add all that up, we add all of those numbers up, we're gonna get a total R value to that wall.
At 2.9.
So what is it, what'd you get? Still doing it? That's zero.
How do you add the formula?
Huh?
Just talking about stuff.
You see, we can't add these. Those won't add. And these won't add, we have to add the result of those formulas in order to add them up, just like this formula. So the formula is down here. 1 over phi, 4 over 9, 1 over phi, 0.25 over 0.81. So we can actually fill this out on the bottom, and that's the actual formula. 1 over 12, that kind of stuff. Okay? So we got the R value of this wall, right? We're not done yet. Nope. So, what we have to do is take that R value, 0.2 oh no, 2.995 and reciprocated back.
What?
What?
It's crazy.
What?
6.34. I got 0.333.
0.333
3, 4.
equals 0.333. Wow.
Amazing.
You know what that is? That's the U. That's the U factor.
You gotta do all that just to find you? Damn. What the hell?
Holy shit.
A single call's gonna take you like
Wow.
30 minutes to figure out.
Wow, we're still not done.
Oh.
So,
Yeah, we just have to find
if this wall is 10 foot high by 50 foot long, right? So what's our square footage of that wall?
It's 10 times 50.
Yeah, usually.
500.
So what is that?
500.
Huh? 100? 5 meters? What?
500.
500. So the area is gonna be 500,
Square feet.
right? And our delta T is what?
So be 40.
40.
40.
How'd you get 40? So it's
You subtract
just subtract the
the
115.
difference.
So it's
The difference.
75. Oh, okay, the difference between them both. Okay, I see what
Yeah.
you're saying.
We got 40. Okay, so we multiply that out, and what do we got?
What, 45,500? That's 2,000.
6,600.
Oh, 6,000.
6,660.
6,660.
Is your
What?
BTU.
Oh, there it is. BTUs. BTUs per hour.
Per hour.
So, that one wall, so how many BTUs are in a ton?
12,000.
12,000. So, how many tons is that? Half a ton. Wow, just one wall. And usually buildings have more than one wall, right? So if it was simple, we'd have 4 walls, right?
Which is never simple.
And if it was the same temperature on all.
Wait, so the 10 by 50 is how tall and wide it is?
Yeah, 10 by 50. I just threw numbers out there. We have to have an area, so. Okay, so if we had 4 walls the same size,
You do it 4 times, times
Yeah.
4.
so what would that be? Times 4?
Times 40.
26,640.
26,640?
640.
Okay,
Yeah.
so just the walls, we're looking at 26,000 BTUs
What's the percentage this is?
per hour, right? Okay. Now, since we've got the walls, usually a building has a roof on it. Wow. A roof?
And then you gotta.
Ooh. Let me eradicate that. Okay, so we know what size our walls are, right? So if we know how long our walls are, we know what our square footage of our roof is too, right?
No. You do.
How long are the walls?
10 by 50.
How long? 50 feet. You got 4 of them. You have square.
Ah, you do have square. You have the area already. So your area of your.
Okay, so if we look at this cutaway of a roof, the first material we're looking at is the faux, which is the outside air film, and remember what that is? 6, okay, and the formula is 1.1/6, and that is what, 0.167?
Yes, sir.
I'm guessing. Okay, so we got roofing. It says right here, rule, 70-pound rule roofing, but it's supposed to be roll roofing. So asphalt roofing, it's on the table is what?
6.5.
6.5?
Yeah.
6.5. 6.5, and that's also reciprocated,
With
which is what?
0.153.
0.153. Anybody else get that? You got that? Good.
yeah.
Okay, next one is plywood. Okay, so it looks like here we got 1.125 plywood. So we're gonna have to figure that out. Cause our plywood, if you look at plywood, the only two sizes they're giving you is 1/2 and 3/4. So we're gonna have to take the K value, which is 0.81, right?
Yep.
0.81. And we're gonna have to figure out what the 1 1/8 is. What is 1 1/8? Decimal.
1.2.
Come on, what's 1 divided by 8? 1/8.
0.125.
1 divided by 8 is
0.125.
125.
1 and 1.25.
1 and 125 divided by 8.81, right?
Mm-hmm. What is that?
And what's that? What's that?
1.388.
388? Okay. Good one. Oh, look, we got another airspace.
Good gracious.
Huh?
Good gracious.
So, we got 24 inches of airspace. What?
What?
So that'd be 1.1 for the K.
1.1. 1.1, and it's a reciprocal. Why does that look familiar? Is that 0.606 or 909? What is it?
909. 0.909.
0.909?
That stays the same.
So airspace is always the same.
Unless it's less than 3/4 of an inch.
Oh, that's when it changed.
Okay.
Is that less, is that more than 3/4 of an inch?
Absolutely.
Okay.
Yeah. Ceiling.
That's really pretty simple, really.
Yeah.
Okay, so next component we have is a ceiling tile, right?
So
What's ceiling tile?
Ceiling. Shingles.
It's under board.
Is it? Poly.
Acoustical tile. Look, that's what we have here. Check it out.
0.8.
0.8.
0.8? Say 0.8?
It's under the board.
0.8? So it's 1/0.8? Is that it? 1/2 inch. 0.8? And that is
1.25.
1.25?
Yeah.
25.
Zero.
Okay, so we add up all the R values, and we'll come up with what?
What about flat?
Oh yeah, like feet,
Not flat,
feet,
feet. Feet.
feet, it's French, feet. Feet is
1.65.
1.65, and 0.606.
I got a 3.867. Is that right? Oh wait, no, because I didn't add the last one.
Yeah, see, you didn't add the last one.
Yeah, so it's 609.6.
What is it?
609.8.
So I got 4.473.
Okay, what is this other apple? I don't particularly care for apple.
What'd you guys get? Got 4.473.
I'm messing up.
Yeah.
4.4, so 4.473, that's the R value.
That's the U. Oh, you gotta reciprocate it.
Well, you guys got 4.473.
So we're gonna reciprocate the 4.473, and we're gonna come up with
2.223.
point,
222.
0.223.
Yeah.
Well, I can put that right here, 0.2, 0.223. And what's the area of our roof?
500.
I don't think so, Tim.
50?
I don't think so, Tim.
50.
What's our walls?
50.
500.
50.
Wall, 50 each wall.
50.
50 times 4, right?
250?
No, 200.
You gotta do the area. It's
Length times width.
250.
Length times width. Square footage is length times width. So what's our length? What's our length?
40.
What do you get for?
50, 50, 50. 200. Our length is 200.
I said 250 because I included.
That's the parameter.
Oh my god.
That's not the area.
So it's 50.
Length times width.
Length times width.
What's a length?
50.
What's a width?
50.
So what's length times width?
10,000. 500. 2,500.
What's 50 times 50?
Oh, 250.
250.
I swear I said 250.
Yeah, 250.
I said four, you know, perimeter. You
Yeah,
gotta add another
yeah.
50 because of the roof. Right?
Multiply 50 times 50.
He's 2,500.
2,500. I forgot to add it.
2,500. And we got the same, we'll assume it's the same 40-degree delta T.
Oh my god, length times width.
So it's
Length.
50, 50, 50, 50.
Yeah, you're doing parameter.
Yeah, so it's just 50, 50.
times. Is that times 0.223?
Yep. It's all times.
I got 22,000. I don't know if that's right.
Yeah. So
Like
22,300 BTUs.
22,300.
22,300 BTU.
So it costs that much BTUs, that much heat, energy.
Just
to
to,
heat the
We'll put this over here.
I think it's to cool
22,300
down the whole house. I guess. That's what
BTU.
BTU you need to have to cool down the whole
H.
house.
Okay?
No H.
Okay? So, this building with 4 walls and a roof is how much?
22,300 BTUs.
The whole building.
The whole building.
You gotta add them.
Oh, wow.
Throughout the walls.
Yeah, I gotta add all
48,940.
48,490,
940.
940. Like that,
Yes. BTUs, H.
BTUs. Yes, we know that.
So just BTUs or BTUs are now?
Hour. This is all hour.
Okay.
Oh, wait a minute, oh. Happy now?
Yeah.
Okay, 48,000 BTUs. How many ton is that? How many BTUs in a ton?
4 ton.
4 ton. Okay, so that building that we're looking at, 4 ton of air conditioning. 4 ton. That's no windows, no lights, no door. And there's nothing else. Just a dark building with 4 walls and a roof.
So Minecraft.
So, check this out. You ready to check this out?
Yep.
Check this out. We will do this, we'll take the same building, let's put some insulation in, and we'll see what the difference is. That's magic. You like my smart board? Okay, so basically we have, I know this not 24 inches airspace anymore. So we put some insulation, it says right here insulation R19. So the insulation, if it's R19, we can go ahead and put our 19 right here. Let's move that over a little bit. 19,
For the resistance.
because that's what we're looking for, is the R value, right? Okay, the airspace changed, but is it
Still the same.
3/4? Yeah, still the same, right? Okay, so what is it, what do we have now? What is it now? What is it now?
Damn. Okay, give me 1 second.
Just add 19 to that way. Add 19 to that number there. What is it?
23.473.
23.473
Reciprocated.
our new our U factor for that will be
0.042.
point
BTU.
042, you say? Okay, so what's our square footage of our roof?
500 or 2,500.
Okay, so what do we got? What do we got? What do we got? Come on, come on, come on. You getting nervous?
I am.
What do you need? What do you need? I'll get it for you. What do you need?
Okay, it's 4,200.
Okay, so here we got 4,200.
Yep.
Okay.
So we're gonna do it for the walls too?
Yeah, we're gonna do the wall, so let me back it up.
Okay.
So, you guys remember what the values on the walls were?
Yes, we do.
Oh, you do? You writing it down?
Yes, I did.
Okay. All right. So, why don't you just give me the R values?
Okay.
That, what's R value? The total?
0.167.
167. Remember that?
0.44.
And what?
Rick, 0.444.
0.444?
Airspace is 0.909.
Okay, we're not gonna do the airspace,
Okay, sheet rock is
because,
0.5.
look,
Oh, there's no airspace.
there is no airspace.
Ah,
We got 3.5 inches of insulation in there. So, if we look at the chart, look at the chart under insulation. Where is it?
none.
Oh, loose fill,
Loose fill. Wood.
Well, you're saying, oh, under glass. So 3.5 inches is 0.091, and we reciprocate that, and you actually come up with 10.989. Or the, so what else you got? Sheetrock?
Sheetrock's 0.561.
And handling,
0.308.
0.308. And
Five.
5.
Fee is 0.606.
Okay, so we'll add that up. Yeah.
13.075.
13.075.
Yep.
Reciprocate that is what?
Zero point zero six. I mean 0.076.
0.076?
Yep.
And our walls are like 500?
Yep.
Okay. Remember, we gotta multiply that by 4, right?
Get to see.
What'd you get? You got 14?
Where?
When you added it all up.
13.
Yeah, 13.075.
Oh, yeah.
Add those together.
What's that one? 40 times 500 times 0.076 is what? What?
1 second.
1 second?
Oh, you had to times that by 4 times 40 times 500 times all that?
4 walls. Usually there's 4 walls.
6,080 BTU.
How do we get the 10.989? Sheetrock?
Where?
Installation.
0.091. One over 0.091.
This goes right here. It's under insulating materials.
Oh, okay.
Dang, bro. You get 79,000?
No?
No.
I got 6,080
For what? One wall?
for the whole wall.
What was this one?
Oh, okay.
What was that?
All that together? Oh, not that?
Oh, without that. Okay.
Oh, the 13.
What is that? 40 times 500? What?
It's 1,520.
Whoa, I got
15.
19,000.
Yeah, 1520.
1520?
I'm not doing it right.
500 times 40 times 0.076.
1,520.
15, so we'll go 15, 20, right? Right there, so that times 4 is what,
6,080.
6,080?
Oh, so you multiply 4,500, 0.76, you get that number 15, 20 times that by 4?
Yeah, these are all BTUs,
Okay.
Yes,
they're
that's
BTUs.
Okay, I see.
BTU, and then at 6, what'd you say, 6?
6080. 6,080.
6080 for 4 walls and the ceiling.
10,280 BTU.
10,280
Yes, sir.
BTUs.
Loads of energy saved. Loads.
Okay, so here's our difference.
That's not even a ton.
Is there a difference there?
It's a huge difference.
Huge difference? Okay. If you don't take anything away from this program that you're in right now, one thing you can take away, you could be an insulation salesman.
See? Crazy, huh?
Whoa.
Mind blowing.
Mind blowing?
Wow. It's easy.
It's a process, but
It's easy.
it's done, yeah.
This is the way it was, this is the way it used to be done. Yeah. This is only one way to do a heat load. You're gonna end up learning how to do about four different ways. And what I would always do when I was doing this, where I was doing, work in the office and I do bids and stuff like that, if I did a heat load, I'd always do it again another way. To see and make sure that I'm right on track. So if I had another way to do it, I could figure another way. So, you're gonna have multiple ways to do it, things too. Okay.
Okay. Plug and play.
Was it way easier now
Huh?
to do it? To do the installation? Is it easier? like,
Easier.
Is it still this whole
Not this
process?
process. This is only one way, there's only one process. This is the actual Title 24.
So
But when they talk about Title 24, that's what they're talking about.
this is all just Title 24. Cool.
And we can do the same thing
The hell's-
with the residential, with and without insulation. We don't need to do that because we're actually gonna do the same thing. It's gonna be roughly, what, 4 times more. 4 times the amount of heat without insulation. 4 times the amount of heat transfer. Okay? So, but on some of this, you got 5/8 inch stucco, you're gonna have to, let's see, I don't know if that's on there. Masonry and gravel,
It's right there.
no, it's not on there.
Stuff was right there.
Is what?
Under cement, more?
Yeah. Masonry materials?
Yeah, cement, mortar, yeah. Masonry materials, yeah. So that would be 5 over 0.625. Right?
You said 5 over.
Yeah.
Or,
Yeah. 6.625.
no, 7.
Is it?
So it's thickness first. Thickness. Right? 0.625
625
over
divided by 5.
5 by 5,
Yeah, 0.125.
0.125. Is that, they
You got
don't
the
give you that.
625 from where?
You
You said what? The 6.65?
Yeah, 0.625.
5 divided by 8.
5 divided by 8, okay, so that's the formula, right? On the stucco?
65 divided by 5.
Right,
Switch to
okay.
this.
The stucco is 5. Oh, no, I put that wrong.
5.0, right?
625 over 5. That's in the wrong column too. The stucco is actually one of those things that's, I've gone through 2 inches of stucco one time. It was a hassle. So you get kinda know.
Okay, that's what you're
Nothing out of the ordinary there, you got what, temperature difference of 30?
Yeah.
Yeah. So. You get the idea now?